As reservoirs get harder to find and more difficult to characterize, seismic imaging has taken on an unprecedented role of importance. To address the growing complexities of this rapidly changing environment, ION created Firefly, the world's first cableless system for full-wave land acquisition. With Firefly, land seismic acquisition is unrestricted by cables, so geoscientists are free to design 3D surveys in a way that more closely aligns with their subsurface imaging objectives. Operators have more flexibility to acquire data in hard-to-access terrain and to shoot denser surveys. The weight and footprint of the Firefly system are reduced, minimizing HSE exposure.
The operational flexibility that comes out of the Firefly system is because we can remove the cables in the field that connect the receivers to the recording system. We can place receivers and record information anywhere that we want to without being limited by environmental issues, urbanization, roads, railway lines, airport runways, rivers, or even mountains. It takes away all of the obstacles that a cable system is really challenged with. Looking at it from a seismic contractor perspective, there are three really main things that impact their business. One of course is cost, one is productivity, and the other is health, safety, and environmental protection.
The sheer weight of the systems are becoming a problem. We have issues with the number of people that it takes to deploy these systems. The HSE exposure alone is becoming an issue, as well as the problems that we face with troubleshooting.
ION changed the game in seismic imaging with the introduction of Firefly. Chris Friedemann, ION's Senior Vice President, explains the vision behind Firefly.
The idea for a cableless system really had been bouncing around within what was then called input-output for a while, but it surfaced in a big way back in 2003 in our first strategy offsite with our new CEO, Bob Peebler. Everyone that heard about the idea and concept of a cableless system became pretty excited about it, and it was sanctioned soon afterwards. We wanted to look at it more as an ecosystem, which for us meant really looking at the whole value chain or whole workflow, all the way from the way seismic surveys were designed to how the data was acquired in the field, the technologies, both hardware and software, that were used in the field for operations, as well as how the data would be processed and interpreted.
The Firefly ecosystem includes all the technologies needed to optimize a seismic survey, including the tools for survey design, the sensors and recording system, and the automated command and control software. At its core is a revolutionary multifunctional piece of hardware known as the Field Station Unit, or FSU. About the size of a small lunch pail, the FSU is able to receive commands to optimize field operations. The FSU is equipped with flash memory that is capable of recording hundreds of thousands of traces. What's more, FSUs can be added at any time to adapt to different survey sizes and shapes, letting the design of the survey be driven by imaging needs instead of equipment constraints. The vector size sensor is another important technology within the Firefly ecosystem. With only one sensor at each receiver station and no need to level during deployment, vector size receivers deliver significant efficiency improvements during field operations compared to traditional deployments of geophone arrays. By recording 3C data, vector size captures a broader range of frequencies to improve resolutions and records azimuthal variations in seismic velocities, making it especially useful for reservoir characterization. A key part of the Firefly ecosystem is Connex, a real-time command and control data management system that acts as the brain of the Firefly-based operation. Route management functionality enabled by Connex guides people, shot hole rigs, and vibrators to their deployment positions along a safe path and with the least amount of visibility and disturbance to the surface. It contains a warning system that highlights potential dangers along route execution. It provides complete visibility of operations in multiple locations to deliver tight operational control and verifiable adherence to HSE rules. Since its introduction only a few years ago, Firefly has evolved even further, with the learnings from the BP and Apache field trials incorporated into the system. The first deployment of version 2 of Firefly took place at Durham Ranch, Colorado, just outside of Steamboat.
I'm standing in the Williams Fork Valley of Moffat County, Colorado, and we're in a very environmentally sensitive area and a very topographically challenging area. Behind me are some of the cliffs that we're dealing with, class 5 and 6 cliffs. One of the big issues with the topography is it's very difficult to move equipment up and down those cliffs and move people up and down those cliffs safely. The reservoir we're exploiting out here is a fractured shale reservoir that's at about half mile to a mile and a half deep. And for the most part, what we're using this seismic program for is to target where we're going to put our horizontal wells. Normally you would use seismic for exploration, but in this particular case we're using it for exploiting the reservoir and placing the wells. This survey couldn't be shot without using Firefly in the Connect system.
Firefly introduces a survey planning process that results in faster, safer, and more effective operations. As an integral part of the planning process, Mesa Survey Design software optimizes source and receiver locations based on imaging objectives. To provide the best possible use of batteries in the system, Power Modeling optimizes the energy requirements within Mesa. To facilitate operations, the staging trailer is specially equipped to handle all Firefly gear and conveniently handle charging and recharging in the field. Firefly eliminates the excess weight associated with cables and reduces the amount of equipment necessary for a survey, resulting in a more cost-effective land system with much less health and safety risk to field crews.
We've already noted so far that we've maximized our efficiency probably 3 times faster than anything that we've ever used in a cable system in the past. We also believe that it's safer as we move through the terrain with lighter equipment as well.
The Firefly navigation tool is equipped with GPS technology that directs the user to the precise planned location for planting the receiver. It also tracks the units back to their location of deployment for pickup. The nav tool includes a simple user interface that enables field crews to enter final deployment parameters, along with drop-down menus and intuitive instructions that guide the user through the process of deploying a field unit. The nav tool is also Bluetooth enabled and wirelessly receives information from the digital compass located on the navigation pole for synchronization and accurate positioning.
I see many advantages to it, mostly in the HSE department, which is for a guy in the field is the most important. The cables, especially in a mountainous terrain, there's a lot of hazards, but with no cables, it makes all the difference.
Firefly is designed to work with both dynamite and vibroseis energy sources. Containing similar GPS technologies to those used in sensor and FSU deployment, the nav tool navigates the shooting crews to the exact location of either the dynamite or the vibrator source. It makes finishing the job simple and easy. When field equipment needs to be retrieved, the nav tool guides field personnel back to the location of the sensors and FSUs for convenient and fast pickup. Crews are able to just grab the equipment and go. Once the equipment is picked up and returned to the staging trailer, the data is ready to be downloaded and the field station units can be recharged. Back at the central, the integrity of the information is monitored and the operator ensures that it is properly downloaded for processing. With Firefly, operators gain new insights into the operation and more control than ever. From contractors to oil and gas companies, the challenges the industry faces today are many. Productivity demands are escalating, HSE pressures continue to increase, and operators need to be able to work in a diverse array of environments. Firefly addresses these issues and more. In a word, it's a game changer.
For us at this stage, having a lighter system, having the flexibility to move around the terrain with that lighter equipment, and having it to be less cumbersome is clearly the future.
We can design from the subsurface upwards and decide where exactly on the surface we need to put the receivers to be able to record the right information.
I do believe it's the system of the future.
It's now battle-tested, battle-hardened, and we're really looking forward to rolling it out to contractors around the world.
I'm Bob Peebler, President and CEO of Ion Geophysical. When we first conceived the Firefly almost 4 years ago, we really based it on 2 ideas. One, we'd have more challenging imaging problems, and 2, we would be in environmentally sensitive areas such as you see here. Now, I'm just delighted to be on our first commercial Firefly shoot, and I can tell you that I'm looking forward to the future of Firefly. It's an exciting journey that we're just at the beginning of.